here's what's meant to be a couple of introductory examples to the product rule. So we're going to differentiate first y equals 6 times the square root of x times cosine of x. Now it might help to begin by doing a little bit of rewriting so that we express the square root of x here as an exponent, so that we can now then, when we differentiate, use the power rule. So I'm going to express this square root of x as x to the 1/2. That's an equivalent expression. And I'm starting to color code this just to help show what's going on with the product rule. Okay, so we've got the square root of x expressed as x to the 1/2 and then cosine of x. I know that green isn't great. Okay, let me use purple instead. Here, and I'll just hope that the purple looks different from the black. Okay, yeah, that looks pretty good. All right, so just color coding the components of the product here. So now, if we differentiate, so y prime. Now, first of all, so as far as how we want to treat the coefficient of 6 here, I guess, so we want to look at our product as, let's look at it as the product of two functions. So I'm going to look at it as, here's my first part of the product, 6x to the 1/2. I'm going to include the 6 with the first part of this product, just the way I'm going to choose to handle it. And then cosine of x is the second part of the product. So let's say we differentiate the first part of this first, which, by the way, with the product rule, let me jot it down. So if we have y equals, let me even use similar color to what I have here, right up here. So if we've got some function f of x times another function g of x, then y prime is equal to, and this may not be the order that I have it typed in the notes, and it's okay. I mean, my point is going to be that we don't have to worry so much about order with product rule. The main thing is that you differentiate one part at a time. So say we differentiate that first part of the product first, so I take f prime, then I should leave the g of x alone, and then it's plus, and then you flip it. So now I'll leave the f of x alone and differentiate the g of x. Now, like I said, pieces of this might be written in a different order when you look at the product rule in your notes or in your textbook, but when we're multiplying, order doesn't matter. So it doesn't matter if I write this as g of x times f prime or f prime times g. Same thing here. And with the sum, that order doesn't matter either. If it's 3 plus 2, it's the same as 2 plus 3. Addition is commutative, so is multiplication. So the only thing you have to keep in mind when you're using the product rule is that you differentiate one part of the product at a time, leave the other part alone, and then add to that, reverse it. Take the derivative of whatever you left alone, leave alone whatever you took the derivative of. So I'm going to do that here. So f prime, so if I differentiate 6 times x to the 1/2, 6 is just a constant coefficient, so I'm going to leave that alone. And then with the x to the 1/2, that 1/2 power comes down, and I take 1 away from the exponent. So when I subtract 1, 1/2 minus 1, that's negative 1/2. Okay. Leave the cosine x alone. And now we add to that, I'm going to erase what I have over here since I need that space. We're going to add to that, now we'll differentiate the cosine x function and leave the f of x alone, the 6 times x to the 1/2. Okay, so unfortunately that can't stay on the board. All right, so we're going to leave the f of x alone, so 6x to the 1/2, and differentiate cosine x. Derivative of cosine is negative sine x. And I'm writing parentheses around the negative sine x just to denote the multiplication here. So it's not 6x to the 1/2 minus sine x. We're multiplying those times each other. So now we've taken the derivative. We've applied the product rule. Now it's just a matter of cleaning things up a bit. So I would go ahead and multiply 6 times 1/2. That'd be 6 over 2, which is equal to 3. X to the negative 1/2. So that's going to be a square root of x in the denominator. The fact that it's negative moves it down to the denominator. And the fact that it's the 1/2 power makes it the square root, equivalent to writing square root of x. And then cosine x. All right, plus, but then when I multiply this, I'm going to get a negative 6x to the 1/2 sine x. So I'm going to go ahead and bring that negative to the front. 6x to the 1/2, I'm going to switch that back to the square root notation, sine x. Now, depending on if the instructions in the problem are for you to simplify or not, you could stop here if you're not specifically asked to simplify. If we did want to simplify this, we might want to combine over a common denominator. So if we did want to combine these, I'd have to look at this as, okay, well, here's an expression. I'm going to think of it as being over 1. So if I want to get a common denominator, I'm going to have to multiply the top and the bottom times square root of x. So that both of these expressions have denominator square root of x. So we can write one big expression with square root of x on the bottom. And then just combine the numerators. So 3 times cosine x here minus, okay, now if we multiply what's here, you've got square root of x times square root of x. That's equal to x. So this is minus 6x. When you multiply the square roots times each other, and then sine x. Okay, now you could factor out 3 in the numerator. I'm sorry about the glare from the window there. I don't have the perfect setup, but yeah, that's a little hard to read. But what this says is 3 cosine x minus 6x sine x over square root of x. There, I blocked the glare for a second. Okay, so that's example A. What about example B over here? So I'm going to have to get rid of this. All right. So if I take the derivative of f of x over here, all right. So looking at this one, let's just take one thing at a time. First, we want to take the derivative of, and maybe I'm going to write this notation. First, we want to take the derivative of x cubed times sine x, and then we want to take the derivative of 5 cosine x. And there's a property of derivatives that says if we take the derivative of a sum, we can just take derivative of the first part plus derivative of the second part. So that's what I'm denoting here. Now, when you take the derivative of this, you need the product rule, because we've got one function, this is x cubed, times another function, sine x. So we're going to have to use the product rule here. You do not have to use the product rule when you differentiate 5 cosine x, because this is just a constant times cosine x. You could use the product rule for the record. If you want to look at it as my f of x is 5 and then my g of x is cosine x, you can do that. But we already have a process for if it's a number times a function, there's a separate property that allows us to do that more quickly. Okay, so we'll talk about that in a second. Let's do product rule here. So f prime of x, the derivative of f, is going to equal, okay, I'm going to keep the same order I did last time just for consistency, but again, the order is not critical here. You'll get an equivalent answer if you do it in a different order. The important thing is you take the derivative of one part, so let's say I differentiate x cubed. Derivative will be 3x squared. The power comes down, take 1 away. That's the product power rule, I'm sorry, for derivatives. Leave the sine x alone, plus now we would leave the x cubed alone and differentiate sine. Derivative of sine x is cosine x. Okay, and all of this is the derivative of that first part using the product rule. So now move over here. So the derivative of just a constant times a function is equal to, we just leave the constant alone, and then we take the derivative of the function. So in this case, cosine x. Derivative of cosine is negative sine x. So this is 5 times negative sine x. All right, and then the only thing I would do to clean this up then is to move the negative in front here. So for final answer, we could write 3x squared sine x plus x cubed cosine x. All of that is applying the product rule to the first piece here. Minus 5 times sine x ends up with a negative in front because the derivative of cosine is negative. And that would be your final answer for B.